Have you ever wondered how nutritionists tell how many calories are in your favorite foods? A granola bar having 180 calories, or a piece of pizza having 520. What if you want to have a splash of this delicious creamer, or you're hankering for some yummy Triscuits? On the side, the nutritional facts always show you the number of grams of sugars, complex carbohydrates, fats, and proteins. We're going to teach you some simple chemical tests using indicators to assess a variety of liquefied foods. The liquefied foods that we are testing today include apple juice, butter, egg white, gelatin, honey, lettuce, corn oil, mashed potatoes, and an unknown. We're also going to use distilled water as today's control. For every single one of these procedures, we will distribute approximately 5 milliliters of the liquefied food into a clean test tube. Every one of our test tubes is labeled with the abbreviation.
All right, so our first test, we're going to be testing for the presence of lipids. An example of a lipid would be a fat, an oil, cholesterol, etc. And one easy way to test for that is something called the paper towel test. What we're simply going to do is take a drop or a finger drop of the solution and place it on a piece of paper towel and give it time to dry. If it has lipids in it, it will create a translucent surface on the paper towel in which when you hold up to light will easily pass through the paper. To do that, we simply just go down each one of our solutions and just get your fingertip wet and put a drop on each piece. Make sure you change your fingers each time because we do not want to contaminate one sample to the next. And you're simply going to put a drop in the corresponding spot on the paper towel. Okay. And the last one's the unknown. Who knows what's in there? All right, so we're gonna have to set this aside for a little while and give it time to dry, and we'll see which one ends up being translucent.
It's been 15 minutes and now our paper towel is dried.
All right, so part 2 of our test for lipids includes testing the polarity of our solutions. A food that is soluble in water will easily mix when I add water to it. However, if it's a lipid or a fat, it is not going to be soluble in water, and it will actually create its own separate layer above the water. So that's one easy way to test. And so I'm simply going to add about a finger's length of water to these test tubes and see if a second layer forms above the water. as you're going from sample to sample, you want to look for a distinct layer above water. For these two right here, the egg whites and the gelatin, you see a foaming action that took place above the solution. That is not a layer of fat that you need to be worried about. That's just some foam. And that if we gave it time, it would probably settle down. Okay, but are there any clear layers that you can see? Definitely with the butter, I see two distinct layers. With the oil, I see two distinct layers. And with the unknown, do we happen to see two layers amongst all the contents of this poor guy's stomach? Well, it looks like there's a small layer right at the top.
We're now going to test for a type of carbohydrate known as simple sugars. These are found in sweet treats like candy and fruit and cakes. The indicator that I'm adding to each of the food samples is called Benedict's solution. This is blue and is irritating to your skin. So of course we're going to exercise precaution, wearing our lab apron and our goggles. I'm adding 5 drops of the Benedict solution to each of my tubes, including my distilled water control. As I agitate these, I'm transferring them over to a hot water bath. This hot water has been boiling at 200 degrees Celsius. This will help to catalyze the reaction, speeding up the color change that we're looking for. A positive test result for simple sugars will be a golden orange color. It takes a couple of minutes for this to incubate, usually around 3 or 4 minutes. So we'll come back and check the results momentarily.
In this part of the test, we're going to be testing for complex carbohydrates. They are a longer branch of sugars. They give us long sustainable energy. Okay. The indicator we're going to be using for this test is iodine. Iodine will typically turn dark black or like a brown color in the presence of starches, which are the complex carbohydrates we're looking for. I'm simply just going to add a few drops to each one of our
Our last test is for proteins, like you would find in meat and cheese and beans. I'm using another blue indicator that's called Biuret solution. We obviously have to be very careful to make sure that we don't mix up Benedict solution and Biuret solution, which both begin with a B and both are blue. This solution does not require heat in order to react. We're looking for a lavender color. Lavender would indicate the presence of proteins.